Hi everyone, my name is Sabrina Mir and I work for the Young Scientists Program at USC. Welcome to week 4. We'll be learning about parachutes this week. Okay, so the question for this week is, how do parachutes work? So I want you guys to pause this video and make a prediction on how you think they work. So before we start our experiment for the day, I want you guys to pause this video and go watch the 2 videos that are linked down below in the bio. They talk about NASA's project to Mars and how they used parachutes to help make this mission work. Okay, I hope all of you have watched those videos and enjoyed them. So here's some fun facts about the parachutes from those videos. This is the largest parachute ever that they used to make a vehicle land on the red planet. The parachute doesn't even fit into NASA's largest wind tunnel, which is the size of a football field. Can you believe how big that is? What is a parachute? A parachute is a device that helps slow an object that's falling from the sky. So this helps by creating wind resistance. What is wind resistance or air resistance? It's the force an object needs to overcome when it's moving through the air. So do you guys remember last week when we talked about gravity? Gravity is the force that pulls objects down. Wind resistance actually works in the opposite direction of gravity. So it works up and counters gravity. So instead of the object just coming down fast with the force of gravity, wind resistance will help keep it in the air for a longer time. Why do you guys think it's important for NASA to have parachutes on their vehicles to help make things land slowly? Let's pause this video and make some predictions. So there's actually quite a few reasons why NASA would want to make their objects come down more slowly. One reason is in a lot of their vehicles, they have astronauts, right? And if there was no parachute, the object would just come crashing down, and we want our astronauts to get back safely. Another reason is a lot of these parts in their spaceships or space vehicles, they want to use over again. So if the object was not slowly reaching the ground, a lot of these things would be damaged and couldn't be reused in the future. So for this experiment, we're gonna make our own parachute. So you guys will need a few materials. One material is a paper or plastic cup. You'll also need some string, something that you can use to make a parachute, so a napkin or a coffee filter. And you'll also need a payload, so something heavy that can help pull the parachute down or the whole vehicle down. So I'm going to show you guys how I build my parachute. Afterwards, you can pause your video and make your parachute however you want to make it. So first you'll need to cut 4 holes on this cup as you see. Then take some string and cut 4 equal pieces of string. I made mine about 6 inches long. After that, you'll begin to cut holes in your paper coffee filter and then tie the string to both the cup and the 4 holes you cut on your paper or coffee filter to attach them together. Lastly, add a payload. I use pennies. Do you guys have your parachutes ready to launch? Okay, so what we're going to do is stand up, put the parachute above our head, and release it. Make sure you time it to see how long it takes to reach the ground and how the payload affects it. So if you have a heavier object in your cup, will it go faster or slower? What do you think would happen if you had a heavier or a bigger parachute too, compared to the one you had? It would make it go slower. If you had a smaller one, it would probably go faster. Besides NASA and their space vehicles, what other things do you think you'll need a parachute for? I want you guys to pause this video and make some predictions. Why else would you need a parachute? So one scenario where you would need a parachute is if you're skydiving. So if you jump out of a plane and fall towards the ground, you want a parachute to slow you down so you can arrive to the ground safely. The diverse scientist for this week is a female mathematician by the name of Dorothy Vaughan, who worked at NACA. NACA is the National Advisory Committee for Aeronautics, but they turned over their power to NASA now. Dorothy Vaughan worked in the West Area Computing Unit, which was full of female African American mathematicians, and they were human computers, so they did all of these hand calculations for NACA to help send satellites to space or help send a man to the moon. These women worked in a time where segregation was still prevalent, so they weren't allowed to work with a lot of other people at NACA, but Dorothy Vaughan was especially important in paving the way for women to work in STEM in the future. Thank you so much for watching this video. I'm so excited to see you next week for week 5.